if the universe gives an answer to every question that we ask of it, maybe it's because somehow or other associated with that universe is something which is like intelligence. Something of the nature of intelligence is somewhere involved so that science works. And you notice when you ask that question, why does science work, that itself is not a scientific question. That's not a question of science. Why does science work is not a scientific question. It's a philosophical question, a metaphysical question. So there are other ways of knowing than just scientific. I mean, scientific ways are magnificent. They're beautiful. I spend my whole life in them. But there are other ways of knowing. So, and that's why Einstein would do it. He would say, look at the fact that science answers the questions that it raises if they are well phrased, if they're not self-contradictory. If you ask a self-contradictory question, of course there isn't any answer because there really wasn't any question. That's those things that people love. Can God make a rock so heavy you can't lift it? What happens if an irresistible force meets an immovable object? Well, these are all self-contradictory questions. So they're not really a question at all. They're use of words, but they're not saying anything. If you have a valid scientific question, our belief is that there is a scientific answer. All right? Now that's faith, natural faith. It's not a religious faith. It's a natural faith. But once you have it, if you ask the next question, why is science possible? Why does science work? And that was Einstein's question. His atheistic friends always used to get furious at him for that, because they wanted to make him into an atheist, which he was not. He was not. So my answer is yes, I do believe in evolution. I believe in an evolution which is cosmic, which starts with some kind of an initial state of the universe and goes through astronomical change and development, coming now to something like an Earth on which something happens which leads into the existence of self-conscious human beings. Yes, please.
Do you ever think they'll get closer to finding out an answer that'll make both sides happy?
Oh no, no. I frequently, I'll raise with my students this question. I'll say, now assume that as we go on with the space program, we finally come to another planet which has intelligent life on it. So we have this other planet, we discover that they have intelligent life. And we go to them and we ask them, do you believe in God? I can tell you what the answer will be. One half will say yes and one half will say no. Because that question, that I asked there is, why is science possible? That's a fundamental question that faces every person, and every person is going to answer it. And some are going to answer it one way and some are going to answer it another. And that's always going to be true. Some of my atheist friends will say, well, as science gets stronger and stronger, finally religion will vanish. No, it won't. Because that question will always be there. Why is science possible? Why does science work? Why is the universe transparent to intelligence? Why, when I ask a scientific question, does there have to be, there always be, we think, a scientific answer? And that question is going to be there forever. It never will go away. And therefore, there will always be people who will say, don't bother me, I have other things to do tonight. And that ends that. And other people who will say, well, if the universe is transparent to intelligence, if every intelligent question you ask gets an answer, maybe it's because somehow or other associated with that universe is something which is like intelligence. And that's philosophically, not theologically, that's philosophically what we mean by God. So you're always going to have, you can write a science fiction novel about the new world that you discover, and you will find that half the people will believe in God and half will not.
Does anyone else have a question? It's not often we get to talk to a physicist here in the psychology department, area here, so it might be the first time it's happened in, back there shortly after the Big Bang, but I don't know that this has occurred. I'm just sort of curious, since I'm in the psychology department, I'm concerned about anxiety in the physics department, particularly as relevant to the CERN experiments recently.
About neutrinos?
About the neutrinos.
About neutrinos.
Has there been any more about that? I just saw the notice of it and people getting hyper about it a couple of weeks ago. Has that gone on? Is there any explanation for that yet? Are you still researching to find out whether the machinery was working and the measurements were correct? Or was Einstein wrong?
Neutrinos are among the most mysterious realities we face in the physical world. We're fairly well convinced they're there, but they are terribly, terribly elusive. They have no electric charge, and they have essentially no mass. Well, then how do they interact with anything? With no electric charge, so you can't go through electricity and magnetism. With essentially no mass, maybe some trivial amount, no gravitational interaction, how the devil do you get these things to interact? And the answer is, it is furiously difficult, enormously difficult. So we work with them all the time and struggle with them all the time. But if you ever hit a problem and you really don't have an answer, and the physicist is bugging you to give an answer, you can always say, it's neutrinos they're doing. And the physicist will not be able to deny it. We don't know, these neutrinos are really puzzling. They are just enormously difficult to handle. Very hard to measure, very hard to get to interact. There are billions of neutrinos in this room, all over the place. They're all over, and they're all going right through your bodies. Right through your bodies every moment. You don't even notice it.
The few schizophrenics we have in the room are greatly fearful of your comments here, I can tell you that.
So, our first reaction is everybody would like to prove that Einstein's wrong. Before his day, everybody wanted to prove that Newton was wrong. It's not surprising. Everybody now wants to prove that Einstein's wrong. If he's wrong, fine. Whatever the evidence is, the evidence is. And if there's a better theory, fine. We do know that Einstein's theory, the basic theory is general relativity, is not complete. Because there is something that we know that doesn't work. And here's the sort of thing. If you're dealing with a very large objects, galaxies, universes, you use general relativity. That's what functions at that level. But if you're dealing with the very, very small, with things like neutrinos, electrons, protons, neutrons, you don't use general relativity, you use quantum mechanics. And those two theories have totally different ways of looking at the universe. You can't put the two of them together. They really collide. But there's one moment when you have to use both of them. That moment when the whole thing was right close to each other. Because in that moment, the large object, the whole object, the universe, you have to use general relativity. But that whole object now is small, so you have to use quantum mechanics, so we can't. So we don't know how to get quantum mechanics and general relativity together. So when you get to the Big Bang itself, we don't know how to describe it. So we know there's going to be a lot still to come. So maybe some new development of Einstein will be possible. We don't think this experiment is it. Well, why not? Let me give you one example. A few years ago, there was a supernova explosion. Supernovas are large stars that become unbalanced for a variety of reasons and explode. Now, when they explode, it's a big explosion, all kinds of things happen. And among other things, a lot of neutrinos are developed. So that means that we had this big thing happening. It happened several million light years away. That's a long, long distance. Now imagine that light and neutrinos don't move at the same speed. If light and neutrinos don't move at the same speed, and you have a long distance, and they're all a little different, one's going a little faster than the other, they're going to spread apart. And when they come to